Hello and welcome back to the Oxford MAT Livestream. I almost jumped the gun there on the transition. Great to have you with us. We're going to do some maths questions. That's the plan anyway. Oh, let me make that large. There we go. As always, we're joined by you at home in chat and watching either live or on the YouTube recording. And the plan is that we do some math questions this week, taken from the 2020 past paper, which I have on this whiteboard, so that we can do questions together. Let's have a quick look at chat. Oscar says, hey. Hey, Oscar. How are you doing? And Shrishta's excited about the maths. I'm going to read that as a kind of excited, aha, kind of noise. I had a quick chat with somebody about undergraduate and postgraduate up there. The MAT is the Maths Admissions Test. It's used for undergraduate maths at Oxford. Postgraduates do other stuff, not including the maths test. They thought the MAT looked quite basic, so we cleared that one up. Good, okay. As always, I like to start by doing a quick poll to find out how your day is going. It's the 3rd of October when we're doing this live. Let's find out how people doing on this fine day in October. All right so far. Maybe not so good. Okay, good. I won't commentate the poll while it's going. Got quite a few people here, which is nice. Let me check I've got all the things in the right places. I've got Callie moderating chat. Thank you, Callie. Callie is a current student here who's going to keep an eye on chat, possibly answer questions if you put them there, but maybe not things that Callie doesn't know the answer to, like why isn't MAT open to everyone, like Step and Tamua? It's a big question. In a way, it's an admin question, really, isn't it? Why isn't it just open to everyone? Why don't we just make it anybody can take the maths? It's an admin question. It's also a finance question. You might notice that maths doesn't charge people to take the test, and that possibly other tests might come with a charge for people taking them. Hello, Matthew and Skog and Anna. Oh, good stuff. Skog says Skog morning, everyone, which I think is it's important to have that kind of personal brand, isn't it? Good. I'm always looking out for people who vote for 1 star in the poll. Where are they? There they are. People who vote 1 star in the poll are having, let's be fair, a terrible day, and they have still turned up to do some maths, which I think is commendable. So all the best to those people, and of course everyone is. A lot of you people having a lovely day. Look at you, off you go. What is that on average there? 4.0. That's high for us, isn't it? Good. And hello to Katie, who's just got in there as well. We're going to start by doing the question in the thumbnail, and then if you're asking an A-level question up there, I will get to it at some point after I've done the first question, because I know that some people like us to just get on with a question, right? Later on in the show, we will do some voting. We will have democracy taking over for which questions we're talking about. It's a whole thing. Let's see. Right, okay. Tell you what, meet you halfway. Here's a question on screen. We're asked which of the following expressions is equal to, and then it says log base 10. I love a logarithm. Logarithms are brilliant. 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. There you go. Careful not to say 0, otherwise, oh no. If you put a 0 inside, it's terrible. It doesn't work at all. So there's several options. You might notice about the options that they all seem to involve log 2, log 6, and maybe log 7. You might have opinions about what you're supposed to do here, how you're supposed to separate out this logarithm into these different parts. And there's definitely going to be some algebra to do. Once you've decided what sort of approach you might use, there is then some counting or algebra to do. So like a lot of math questions, this is testing both your ability to kind of do something weird or do something unfamiliar that's not very prompted. You're not being told precisely what operations to do, so there's an idea there, but then also get to it by actually doing stuff. Yeah, so people in chat are maybe going to tell us about logarithms. Here we go. Right, okay, so I'm meeting people halfway. I'm going to try and catch up with chat a little bit. Awa says hello, hello Awa, and anonymous, hello anonymous, which is a good reminder that you can be anonymous in chat. What was the A-level question? If you take 3 A-levels in year 13, is it fine to take A-levels? We have a policy on our website about maths in year 12. Short answer is that maths in year 12 is fine with us in the maths department. That's how we think some people do maths and then further maths in year 13. The standard advice is that we would normally count the maths in year 12 as part satisfying our standard conditional offer. But short answer is don't do anything, you're fine. Long answer is have a look at the maths department bit of the website, or search for UK qualifications, University of Oxford. We've got some advice about logarithms. Eva wants to know about the flashcards. Eva, I'm biased, I made the flashcards. I think that they're an option. I personally don't use flashcards. I'm not a flashcard person, so I didn't make them for me. I made them because other people wanted them and thought they'd be helpful. I think if they're helpful, they're probably helpful at the stage where you're trying to build fluency with A-level topics. So, for example, something it's trying to train you is that when you see logarithm of a product, you maybe think about splitting the logarithm up, like how Shrist in chat is talking about splitting up log of thing times thing times thing times thing. That's to split those apart. Right, prime factors. Good. Oh, anonymous person withdrawn their Oxford application. That's quite sad. They put a sad face as well. That is sad. Sorry to hear that. We haven't even got to the deadline, so I don't know if that means. I don't know what that means in terms of UCAS. Whether it's possible for you to now apply to 5 UK universities, not including Oxford. I don't know if you're allowed to start again. Yeah. Nobody wants to write a reference to SCOG, and that's a sad face. SCOG, there is advice on the UCAS website about finding a referee on the UCAS website because it applies to all universities. This idea that you have a UCAS reference. They don't have to be a teacher at a school; they can be a tutor. Right. Okay. Should we talk about logarithms? Let's talk about logarithms, and then I'll try and catch up with chat again. I've got to switch between them, otherwise I will just talk to chat, and people watching the replay would maybe like me to get on with the maths. I do read the comments. We don't get a lot of comments, but the ones we do tell me to get on with it a bit. So off we go. My plan is, I think, to combine these together, or kind of to combine them together, right? So all of these have got the format of like a plus b log 2 plus c log 10 6 plus like maybe log 10 7 for some values of a and b and c and d. If I squint, then they all kind of look like that with different numbers in there. So that's my idea, that maybe I could combine these together. So for me, I'm thinking about squashing these things back together again. So for example, this thing where you see number times log of something. When I see that, I'm thinking like this. And if this step looks like magic to you, then maybe I'm wrong. That would be fun, wouldn't it? Maybe I'm wrong. Or maybe this is just a logarithm fact that, yeah, okay, I think we're good. Katie's got an answer which is none of the options. Yes, Katie, there are other things that you could write, I think. Other combinations of log 2 and log 6. There are others, yes. I mean, in some sense, this is a logarithm, right? There are loads of things that are equal to this number. I think maybe there's only one of this format, I think. For example, I'm pretty sure that this power of 7, I'm pretty sure should be, it's not quite included there, is it? But I think there's only one 7. Okay. So yeah, I read this as something like, that this is, if I bring these together and also cheekily write this one as 2 to the a, 5 to the a, I think about prime numbers because I can see some 2s and 7s around. The fact that 7 was prime was relevant for it being the only 7 in there. Not plus, multiplied. Oops. I should use the flashcards to get better at my laws of logarithms. Good. Okay, so I've got log base 10 of 2 to the a plus b plus c, 3 to the c, 5 to the a, 7 to the d. And on the other hand, I could factorise these numbers and work out what the thing in the question is in kind of a similar format. And maybe you did this the other way around. Maybe you prime factorised everything at the start. It's not quite primes though, is it? Because 6 is not a prime number. So I'm kind of converting both of these into a common format, which is log base 10 of a whole bunch of primes. Yes. Am I kind of quiet? I could be, couldn't I? Hang on a second. I'm at full beans, I think. Hang on, am I using the wrong microphone? I'm using the correct microphone. Hello. Tap tap. Sorry. I think that is maximum. I'll just talk louder. Right. Sorry to headphone users. Here we go. I'm going to compare these terms and those terms. Katie in chat's got an answer. I like it when people in chat are faster than me. Gives me, hope for the future and stuff, right? That 2 times 3 is 6. 2 squared, 3, and another 2. Oh my goodness, only just fitting next to chat. There you go. So it's a counting problem now, isn't there? There's 1 7 in there. There are 2 5s because 10 secretly contains a multiple of 5. So I think A might be 2 for this number down here. D might be 1, but then I've got feelings about the 3s. 1, 2, 3, 4. And then I've got to be careful with this because this is not just the number of 2's, which is 1, 2, 3, 4, 5, 6, 7, 8. I think that A plus B plus C is equal to 8. So C is 2 or something like that. Is that one of the options? No. What have I done? Is it close to one of the options? Yes. What have I done? 2 plus, what am I looking for? 2 plus, I've got C down here twice. Why have I done that? Do I mean B? 2 plus 2 log 2 plus 4 log 6 plus log 7. There we go. I think I've landed on option C. 5 is 10 over 2, and a fact that you might have known already. I've got C equals 2 and C equals 4. Thank you, Addy. Right, okay, let's read people's things in chat. 5 is 10 times 2 to the minus 1. Yes. Good, it is C. We've got to C in the end. I tripped over at the finish line, but people in chat are way ahead of me, so we're safe. As a team, we've got this. Oh my goodness. Which letter of the alphabet is which? But hey, I advised everyone on 10 being 5 times 2. So at first glance, I thought the logs of all the primes would appear in the answer. Yeah. Good point. Ooh, split them all up, starting with log 10. Oh yeah, split up each term. That works nicely. You need to decide what to do with 9, because yeah, you'll get some log 3s. Yeah, people got answers. Has anybody linked M to the flashcards? Just rereading chat. And they are somewhere on the MAT page. I think on the MAT Livestream page, if you scroll down far enough, there's a link to some flashcards. What have we got? The bit where I was quiet. Advice for Katie. Starting at Oxford this Monday and feeling a little stressed. Oh my goodness. It's going to be fine. It's going to be great. The first couple of weeks are going to be very strange. Of university in general. We're doing advice for a new incoming Oxford student who said something in chat that I missed, so I'm going to be nice to them. Sorry I missed your message. First couple of weeks are going to be weird. Wherever you study at university, I think it's going to be weird. Lean into that a little bit is my advice. It's probably weird for everyone else. They might be better at pretending that it's not weird, but I think lean into the weirdness. You're going to meet a lot of new people. If you want to reinvent yourself, this is an interesting time to reinvent yourself. If you've always wanted to use a kind of nickname, then here we go. If you want to change name entirely, then here's a new set of people to meet. You can try out your new name. The maths is going to be really good. It might take a while to get used to lectures and things like that, but the lecturers all know that people are starting university new and dealing with everything else that's going on. So you're surrounded by other people who are in a similar boat or who know that you're in the boat. I'm looking forward to meeting my students. Meeting my students is going to be nice because I've got some puzzles for them and I've got some stuff to teach them. Okay, is it in the description? Oscar's got a point there. Is it in the YouTube description? Oh, I think it might be with a little Joker card emoji. M's got it. Good. Katie wants to know about math and computer science, but that's fine. It's a joint honours course. We do it. It's a course that we do. Oh no, they're actually asking about a specific college. No, that's fine. If you make an open application, then a computer algorithm will assign you to a college, and you'll be treated exactly as if you applied to that college. Thank you, Anonymous, for linking to the flashcards. That should have more thumbs ups. That's very helpful. That's exactly the sort of behaviour I like to see in chat. Right. People linking the thing from the YouTube description to the chat. Good, okay. Katie's fine. Katie's going to make an open application and then be assigned a college and treated exactly as if they'd applied to that college. For this year's MAT, it's the same questions for everyone. Please have a look at the description on the MAT page, which you can find from links in the description. You're going to do all 27 of the questions. We've renumbered. For 2024, there are now 27 questions, but don't worry. Right. Thanks, Yang. Has found the flashcards as well. We're getting to the point where I think the flashcards, I don't know, they may be good for fluency. It's a nice thing to play with. There's an online version as well, if you want to play with them online. But you maybe already know that cos squared, when you see cos squared, you think 1 minus sine squared, and vice versa. So that's kind of 2 of the flashcards that you don't need. Good. Yeah, how many zeros are there at the end of 100 factorial? I don't know if that's an interview question. It's a bit too well known to be an interview question. Right, here's the democracy bit that I mentioned. You get to vote in chat for what we do next. We're looking at the 2020 paper, which you can get from the website or on the MAT page. Hopefully, if you have a search for it, it comes up. Or sit back, it's all on screen. Let democracy take its course. We'll see what we're doing. I'll give them a bit of time to vote in chat over there and see if I need to catch up with anything. Oh, it's hard work, this streaming, isn't it? You get questions, you get viewers, you forget to drink your tea. Oh my goodness. What college am I interviewing for? I interview for New College because that's the one that I'm currently teaching for. How long do I time management? There's a time management question. What do I recommend for long questions? I don't know. So something you can do, and varies person to person, is you could take the total number of marks, which is 100, and you could take the total number of minutes in the test, which is 150, because it's 2.5 hours, and you could work out on the back of an envelope that you could spend 1.5 minutes per mark, which I think comes out as being 22.5 minutes for a long question, which is not that much time. I think I'd nudge that up a little bit maybe. We're going to try a long question now. I'm probably going to spend about 25-30 minutes on it with a bit of talking, but then again, I know the answers. I am enjoying Skog. I probably shouldn't say that, but I'm enjoying the Skog user who has decided to talk like a caveman in chat. And they would like to use double angle formula, even though it's not in spec. Yeah, I mean, for multiple choice, anything goes. Multiple choice question, you get the right answer, you get the marks. No one will know whether you used anything like that. For the longer questions where you show you're working out, for the longer questions where you explain your answers and type stuff, it's kind of working out for a question like that. For the longer questions, you are allowed to do anything so long as you're following the instructions in the question. If the question says do it this way, then you do it this way. Sorry, I'm so used to saying the longer questions where you show you're working out that I have to keep reminding myself that this year talking is hard. What's this? Thoughts on Wadham College. Callie has jumped in on thoughts on Wadham College to say pretty good, friends at Wadham College. That's nice. Good. I like all of the colleges. Before people feel they need to quiz me on all of them, there are 29 colleges that have math students, and they're all great. Right. How do rest breaks work? That is a good question. I think it counts as an access arrangement that you need to request when you register for the MAT. I think. Please follow this up outside the live stream because I'm not certain and it matters. Good. Okay. Oh, international student, I saw your question before, sorry, and you've asked it again because I didn't answer it. Let's do this now. Do you think I could get ready for MAT or pass MAT if you're an international student? The answer, I think, should be yes. MAT is based on a very limited syllabus. There is one page of A4 with a list of topics on. If you're studying A-levels or equivalent, lots of things are equivalent, you might have seen similar topics. And really what we're testing is a kind of problem solving, a kind of willingness to take standard maths techniques and apply them in unfamiliar situations. So it's not the case that students doing A-levels spend all day multiplying out factorials inside logarithms. This is in some sense a surprise for everyone who did this test to see a factorial inside a logarithm. That's not something that the UK students had in advance. So I think it should be quite fair in that sense that if you've seen the topics and you're willing to solve some problems, then here's some problems. Okay. And let's do this ubiquitous question based on, not ubiquitous is not quite the right word, but there is a common question that I need to get better at answering. It says it's awaiting UCAS ID. That's because of some matching. We can't do the matching until we've got people's UCAS applications together. My understanding is that once we've got UCAS applications, there will be some matching, and the warning message in everybody's Pearson View Navigator thing, whatever it's called, the warning message will go away once we've done a big bit of matching. My understanding is that this might not have happened for everyone yet. I'm not sure if it's happened for anyone yet, but please do not worry about what looks like a warning message saying about matching UCAS IDs. We've got some admin to do, but that's an admin task for us. Yeah. Specific advice for the new MAT paper, or tips for the MAT paper, things to think about for a question. I'm trying to do it as we go through. We're going to go and look at question 2. I'm going to look at question 2. Which is assuming no show that. So I think you can do. Show that. I can show that 200 is not in S just using text, right? I think we're going to look at question 2 because that's what people have voted for. I'm going to switch chat off the screen. I can still see chat, and if I read out something from chat, I will try to make it clear that I'm reading from not just the voices in my head, but the thing over there. So I can still see. I can see Scott talking about a secret syllabus, and I want to be clear that we don't have a secret syllabus. Okay, good choice of question, chat. Democracy is working. Over the last few weeks, we've looked at a few past questions that come to mind where there have been functions and doubling. And here's another question about functions and doubling. Functions are on the MAT syllabus. Is doubling on the MAT syllabus? Well, not explicitly, but you know, doubling is a thing that you know about, I suppose. Is that a hidden syllabus? I'm not sure. I am sure. Right, okay. We're going to apply f and g to the number 1 in some order. So for example, we might apply g, then f, then g, or we might apply g, then f, then f. It's kind of right to left, isn't it, for functions? They're kind of inside each other, I suppose. Maybe you'd prefer this if it had lots of brackets. I think that would be a bit messy. There's an example here to show how g of 1, which is the number 4, because g quadruples numbers. Yes, just stick numbers together like this, make things like this. And this is nice with binary. There is some stuff about binary on screen here. Let's quickly think about what these mean in binary. If you're writing things in base 2 with powers of 2, if you have a whole bunch of powers of 2 and you multiply by 4, well, congratulations, you now have a whole bunch of powers of 2 and all of the powers are slightly larger. Because when you multiply by 4, that's 2 squared. Powers are nice. Short version. What's this do? So multiplying by 2 is quite nice if you have lots of powers of 2. And then adding 1, 1 is sort of also a power of 2. It's 2 to the 0. So this is sort of, and you get another power of 2. So these mean something nice in binary. Not that important whether or not you interpret them in terms of binary. I mean, maybe it helps a little bit down here, but let's have a go. So 100 is 64 plus 32 plus 4, which I suppose you could write as 2, 4, 2, 4, 6, no, 2, 4, 8, 16, 32, 64, 2 to the 6 plus 2 to the 5 plus 2 squared or something. So 1, 1, 0. Oh, it's going to be bad if I get this wrong. There we go. No 2 to the 1s, no 2s, like this. Yes. Good. The later parts of this question, yeah, let's answer this because it's important. The early parts of this question, I think, are a little bit easier if you keep thinking in binary. And you do have this description here of how binary works. I think the early bits are easier in binary. I think the later bits, you've got to do some stuff anyway. We will get there. Right, okay, I've had a go at writing 100 in binary. And we're going to show that 100 is in S by describing explicitly a combination of F's and G's that achieve 100. So my plan here is to make 100. How to make 100, and you could work upwards to try, like they're doing up here, try applying F's and G's to small numbers, starting with 1, or you can work backwards to say, how do you make 100? What's the last thing that you did? And work backwards. That second way of thinking is useful for later parts of the question, but you can build upwards if you like. That also works. You don't really know where you're going to start off with, so you have to build lots of things. But it's good for you to build small cases. General advice for the map and for problem solving in general. We've seen both of these methods before on the live stream. A little bit in that logarithm question, right? To try working forwards from the kind of starting point, or what you were given in the question, but also to try working backwards from the place you're trying to get to. So here we're trying to get to the number 100. We can try working backwards to see which F's and G's we needed at the end, or we could try working forwards. And some people will try both and meet in the middle somewhere. Yeah, 100 is at even, says Anusha in chat, so probably that hasn't been made by doing F, which always produces odd numbers. You just notice that that kind of observation is something you can see even if you don't know about binary, never seen it before. Odd and even is something that you have seen before. So you can write out things like 100 is G of 25. That's a new question, I suppose. If I'm working backwards, how do I make 25? I suppose now we can, yeah, Sophie says G always gives even and F always gives odd. So that actually gives me a strategy for working backwards. 24 divided by 2 is 12. And then this 12 is G of 3. And I'm getting underneath my webcam now, aren't I? G, F, G. And then 3 is something like F of 1. I think I might have missed some ones in there. What have I done wrong? I feel like I've done something slightly wrong. G, F, G, G, F. Yeah, I feel like I've messed up, but I can't explain why. 12. Let's work it out bottom upwards. F of 1, so 3 when you put it through F, and then the 3 goes into this function to get 12, and the 12 goes there to give 25, and then G gives 100 at the end. Yeah, what did I think was going to happen? G writes 2 zeros on the end, F writes a 1, 2 zeros, F on the end of the initial 1. Right. Why? I was thinking, why is there an extra 1 at the front? But you know. I did this by defining inverses, and Anusha says in chat, sorry, not the voices in my head. And Hannah, thank you for confirming that you've got the same thing as me. You could see the panic in my eyes, I think. There's people talking about inverse functions. Yeah, that's allowed. Using your notation later in solution sounds about right. Yeah, these functions have inverses. I mean, the inverses are a little bit tricky because, well, at the moment the functions take integers, whole numbers, and return whole numbers. The inverse functions only return whole numbers if you put in the right sorts of things. So if you feed the inverse function for G something like 25, then I don't know, does it give you 6 1/4? I'm not sure. It's sort of expanding the domain, the range. Yeah. So if you're thinking binary, like resident Skog might be, you can think about this as appending things, that G puts 0, 0 on the end of the binary number, F writes a 1 on the end, because writing a 1 on the end means shifting it up to make space. Multiply by 2, because that's what place value is in binary. Just like multiply by 10, shifts everything along in base 10. Write a 1 on the end means what? You should write something in this new gap you've got. Yeah. This question, will the MAT contain a logic puzzle? And I really can't comment on what the actual questions are going to be on MAT 2024. I can say that there's a sample test on the website, and that we think that past questions are good practice, and that we think that logical reasoning is important, and that the questions are supposed to test our ability to explain answers. Good, right. Okay, show that 200 is not in S. And at first sight, this is a bit interesting because 200 really is G of 25, right? G of, get it correct, G of 50. And it's not F of anything. So I'd need to, for this show that, I would need to say something like 200 is not odd. So not F of X for any integer X or something. 200 is G of 50, but then 50, and there's something to say about 50, because it's not odd, and it's not a multiple of 4. Bullet point on screen, because I do not have much space. Good. You can write a sentence to that effect, I think. So it's not made by applying G to any number, and it's not made by applying F to any number. Let alone whether or not those numbers are themselves in S. Whatever numbers they are, applying F and G to them does not give you 50. It's quite powerful, really. You're sort of able to say, without working out everything that's in S, I can tell you already that none of them go to 50. So 50 is not in here. You can't get 50 as it's not achievable from any number. The word achievable there, I kind of know what you mean, but you're kind of making me do the work. So when you say achievable, you mean something like it can't be made using F and it can't be made using G, because F makes odd numbers and G makes multiples of 4. And that bit of reasoning is important, because if you're not careful, then what you're just saying is 200 is not in S because it's not in S. And at some point, that kind of does make sense. If you stress the word, like if 200 is not in S because it's not in S, but it doesn't mean anything, right? It doesn't show that I know what I'm talking about. You shouldn't accept that from me, the kind of tautology of saying the same thing twice. You're doing slightly better, but I think you can get a little bit closer to the reasoning, which you do know, right? You know, but you're probably thinking about odds and evens, and then put some of that thinking in the answer. Good, right? Okay. Always encouraging people to write stuff. This is why I'm really interested in having these long questions where people type their answers. You get to explain stuff. We get to see you explaining things. Yes, and Anna has got a solution thinking about binary expansions. Good job. If you're a Maths and CS applicant, then Anusha wants to know, and this is a good question in chat, sorry, whether they should only do Maths and CS long questions, which I think would be 2 and 5, and I guess, I don't know if they think they mean 6. Anyway, it doesn't really matter. All the people who worry about 6 and 7 and past questions and which ones, it doesn't really matter, because what we're trying to practice is problem solving, and that's present in all of the questions. So whether or not you think this question is slightly more computer science than maths because of the binary, I think you get to do pretty mathsy things like talking about odd and even numbers. Hope that's okay. This could probably have been question 6. I'm not sure they're very different. Sorry everyone. I'm grinning like a maniac because I think clearly people think that question 6 is different from the others, but I'm being a bit mischievous. Yep, so part 4 wants us to show that if n is in S, then there's only one combination of applying F and G. There's only one way to do it. So by now, having worked backwards from 100 and 200, and having explained carefully why you can't make 200, we've got strong feelings about this. I would write something like the last oh, sorry, excuse me. The last function applied must be f if n is odd, or g if f if n is odd, g if n is even. Only one way. Either way, that's made a smaller number in S. It's come from a smaller number in S. It's come from a smaller number in S. Sorry for the handwriting. And I would try to say something like, keep going until you get to 1. Keep going until you get to 1. Only one way, or only one option along the way. This kind of method that we've been doing to work backwards works quite nicely here to say, well, along the way you'll either see even numbers or odd numbers, and you know what to do along the way. If it can be made, then you'll keep going. If not, then it can't. What does it say after either way? Yeah, that's the bit where my handwriting goes bad, isn't it? I've put either way, it's come from, gosh, even I can't read that. Either way, it's come from, and I suppose I should be better than that. I should probably go back, and if I'm going to rub it out, I should probably write something better. It's f of x or g of x with x, a smaller number in S. Giving things names is powerful. Here, using the letter x to mean where's it come from. It's g of x or f of x, where x is a smaller number in S. It's powerful. Let's see how much easier that is to read as a sentence now that I've invented the letter x. Keep going until you get to 1. Something like that. Yes, no number of g which equal another number of f. F and g are not commutative. This is tricky. Lots of people did something like this for this part of the question. The point that I would argue is with this approach. So Anna in chat says f and g are not commutative. It's true that they're not commutative in general, but I think they do commute for some specific inputs. Maybe that's not true. Yeah, that's nonsense. Sorry, ignore that. Complete nonsense. Yeah, you need a combination of both arguments, I think. It's not enough to say that they don't commute, because what if applying f 4 times was the same thing as applying g 3 times? That's not a commuting property, that's just 4 f's turning into 3 g's. It's hard to say that that's being ruled out by the fact that f and g don't commute. I'm not claiming any commuting is happening. When I turn 4 f's into 3 g's, this might be the case. In fact, it's not, because the last thing that I applied in those. So there's a subtlety to the argument there to say, if you want to argue about commutative functions, it's not just a question of getting the things in the right order, it's also about how many of them there are. What the last one is. Joseph is applying to Oxford next year, doing IB, higher level. We need to be thorough with the further maths syllabus. I think you're fine. And they're also asking Callie. We accept IB higher level. We accept IB higher level, either pathway. Maths doesn't use any further maths. So if you've come here for maths help, the maths doesn't use any further maths at all. Okay, part 5 and 6, here we go. This is the tricky bit. I think this is probably why people have voted for question 2. How long have I been going on question 2? Maybe 10 minutes, 20 minutes, something like that. Keeping an eye on the clock now, look at this. Okay, we've been asked to show that. I've seen this before. There's Fibonacci numbers, isn't it? Fibonacci numbers. It's adding together the previous 2. Okay, anyway, what is this? Yeah, okay, so UK is the number of elements that lie in this particular range, from 2 to the k inclusive up to 2 to the k plus 1. And we're asked to show that things in that range, is equal to the sum of the things in these two ranges. So this is the number of elements. I should write that out. This would be the number of elements n of S that lie in the range, and then this would be, so UK would get us up to 2 to the k plus 1, but then UK plus 1 takes over and counts all the ones that are in the range 2 to the k plus 1 inclusive up to 2 to the k plus 2. Okay, what's this thing on the left? This is the things, this is the number of elements. I'm trying to interpret the terms on each side, and I've realised that adding means counting in two disjoint ranges, and adding those things together means counting across the whole range. N of S that lie, I'm just writing out the sentence from here, in the range. Sorry, bad writing again. And then what's this? So this is 2 to the k plus 2, less than or equal to n, less than 2 to the k plus 3, because this says you take the subscript, you put it here, and you add 1 to the subscript. Even though the subscript is now k plus 2, I'm doing something similar on these. Okay. Ooh, right. What is this? So, we're doing a bit of counting. What's chat saying? Chat says several things about applying for courses and doing A-levels. Sorry chat, I'm going to get back to A-levels in a second. I want to finish this calculation now. Possibly pushing through to part 6 if I can build up some momentum here. So I'm going to get back to A-levels, if you want to get back to A-levels. Okay, what are we doing? We've got elements in this range, and the claim is, the thing we're trying to prove, is that the elements in this range of larger numbers, well, same number in this large range compared to the number of elements in this small range. That's interesting. What's going on there? I think I need to think about how the numbers are made. I can see some powers of 2, and I know that the functions are about doubling and multiplying by 4. So I think it's about bounds on how large these numbers were and how large they will be when they've been multiplied by 4. Right, so yeah, this range contains multiples of 4 which are 4 times x for some x in the right hand range, in that range, so this range contains things in that range. I'm pointing with arrows, so I should copy this out and write out the ranges that I mean. Some x in that range in S. All of this is in S. So something in that range in S times 4 would be in this range, to give me something new in S in this large range. And it contains, okay, yeah, and it's going to contain odd numbers, which are 2x plus 1 for some blah 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 x in that range. I think this all works out. Is it actually the first half of the range? Yeah, maybe combining these was a mistake, because I think it's the small elements times 4 and the large elements times, yeah, okay. So elements in here times 4, and it's elements in here times 2 plus 1 end up in the large range. And I should check the inequalities to make sure that adding 1 doesn't mess everything up, but I'm pretty sure that's what's going on. That we're taking elements of S that were pretty small, multiplied by 4, and taking elements of S that were a bit larger and doubling them out of 1. And that's how you make all of the elements of S that are in here. There's the only ways to make elements of S that are in this range. Multiples of 4 and this thing. So I think I can tighten up the range. I think I can do better over here and better over here. I think I can. My inequalities will work out to be better on the ranges. Yeah, apply F to the elements that you're counting here. Apply G to the elements that you're counting over there. Good. Okay. I would also like a reminder. Yes, Callie does maths. Somebody else in chat. I should check as well. Okay, more A-level questions coming in because I think I said I would do them in a second. Let's see. So SK is then the number of elements that lie in this whole range. What is that then? SK, everything from 1 up to 2 to the k plus 1. So is that something like 1 is secretly 2 to the 0, 8 is 2 to the 3. So this 1, I think I want SK, this sum of everything, to be U0 plus U1 plus U2. It's sort of all of the things added together, isn't it? These ranges stack together nicely. We already saw that with the adding idea. These ranges stick together nicely. So you get everything up to, there's a k plus 1 here, which I think comes from UK. So I think SK is the sum of everything from U0 up to UK. Maybe it's S for sum, maybe. And we are asked to prove something. So I think, default assumption is that I should do something like replace all the S's with U's and then look at what I get. That's a two-step plan. First step is a thing that I can do, I don't really know where it's going, and the second step, I'm relying on future me to spot what's going on. So I am going to do that. The way I write this is something like wants to show. The thing that I want to show is this. The left-hand side there is, left-hand side is U0 plus U1 plus dot 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 plus UK plus 3, which feels a bit weird, versus the right-hand side is, maybe this will work out because there's some addition of some U's. I don't know why the 1 is there. Look how useless this looks, right? I'm just copying out my observation that SK is the sum of all of these things. Okay, so what I hope is that these things add together, that I can take, what do I want? The rule is that you add together the previous two, so I guess I take them like this, U0 plus U1, U1 plus U2, all the way up to that one at the end. Don't know though. So I think I can replace that as 1 plus U0 plus, and then pink blobs, U2 plus U3 plus U4 plus dot 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 plus UK plus 3. And that is using the previous part to say, you've got kind of two sets of U's. These ones are kind of shifted. If you discount the first term, these ones are kind of shifted by 1. The subscripts go 1 larger. So you can pair these things up. I've tried to draw these pink peanut shapes on screen. That's how I'm thinking of it. And then what is this? So I just need to put, this matches. If U1 is equal to 1? Is U1 equal to 1? It's a thing that could be true, because that's missing somehow on the right hand side. I don't really understand why it's missing, but it's not there. And I have a U1 on the left hand side. Is U1 1? So I think maybe I want to check that U1 is 1. So U1 is the numbers that would be between 2 and 4 not inclusive. So elements of S in this, which is just the set, just 2, 3, and 1 is in S, and then 4 is in S. If you multiply by 4, and then you get larger stuff, and also 3 is in S. We saw that before actually, we saw 3 was in S. So just 3. So U1 really is 1. A little calculation there just to check that I've understood what's going on with small numbers. 2 plus 1 is 3. Welcome to the live stream. Good, okay, but I think I do this just by comparing sides. Sorry if that felt quite fast. You're lost, says chat. Sorry. Let's rewind. The actual maths of what's happening, before I do the rewind, the actual maths of what's happening is not that important. The strategy that I'm using might be useful to you, so I'm going to try and talk about strategy. I don't really care if SK plus 2 is equal to this thing or not. Sorry. lovely formula that I just met, but I don't really care. What I do care is about strategies for approaching these things. Okay, rewind, let's go. I noticed that the range in the question over here, the range in the question was not totally unfamiliar. It's quite unfamiliar. I haven't seen this range before in the question, but I have seen something that's similar. So I spotted when I read this, I thought that's got to be related to the thing immediately above it. So I started by thinking, how are those ranges related? And I realized that this range is sort of all of the previous ones. Not all of them ever, but everything that's smaller than 2 to the k as well is in here. All the stuff down to 2 to the 0, which is why I wrote on the screen 2 to the 0. So then I was thinking about how that's, if you're counting the number of elements, which is the bit in the sentence that I haven't underlined yet, the number of elements, I should add together all the elements in the different sets that together make this new range. That's just me trying to understand the new object in the question. There's a SK, well, I don't know what that is. At this point of reading the sentence, I have no idea what it is. It's a number of elements again. Okay, so probably related. And here's a range. So I've got to relate it to the previous part. Thinking like that is how I got down to this equation of just SK is some sort of summing together the number of elements in different places. And I copied up the thing I wanted to show because I wanted to show it. It's got a left-hand side and a right-hand side. It looks like it's adding together things, which is related to the thing we saw before in hindsight about adding together U's. But my approach to this, which is a bit of a blunt axe, some sort of hit it with a big stick, is to say, well, you introduce this new letter S, I don't like it. I've worked out that it is a whole bunch of U variables hiding together in a trench coat. So when I see the letter S, subscript, when I see this letter S thing, I'm just going to replace it with those familiar U variable things from the previous part of the question. I'm going to unpack it all. So I took their lovely statement from the question and I unpacked it to say, okay, this thing on the left, never seen S before in my life, don't like it, going to replace it with lots of U's so that I know what I'm working with. And I've got to be careful. There's a technical thing about here about sequences that I have to be careful with the subscripts. I have to notice that if I got them wrong, that would be fun, wouldn't it? In the middle of saying I have to be careful, yeah, I'm totally wrong, aren't I? I'm out by 1. That's fun. I'm out by 1 everywhere, so that's good. Who else spotted this? Who will spot this? Maybe people are telling me this. Okay. I'm out by 1 everywhere. But I said I wasn't interested in fixing the technical stuff. Oh my goodness. Plus nothing. Plus 2. I broke it. Did it wrong on both sides, so that's consistent at least. Rubbish. Thank you for making me do it again. Okay, what was I doing? Oh yeah, so I unpacked both sides and then I compared them. As the strategy for proving stuff is to unpack and compare. See what you've got, and if it's the same, then we're good. The fiddly bit at the end was just because they weren't quite the same. There was a spot the difference element where I spotted, not quite the same. But luckily I remember what those few things were. Yes, Addy in chat has now spotted the thing as well, possibly as I was saying it, or just ahead of me. Good. Yes. So our strategy here is to unpack. There's a request to go back to 5, previous part, which is in fact based on the previous part again. The idea for the previous part is just these elements UK plus 2 as the number of elements in some particular range. So I wrote down the range that they were talking about, and I thought that those numbers looked quite large. They looked like, to be honest, multiplying by 4 because of the 2 to the 2 over here, 2 to the k plus 2. It's kind of like 2 to the k, but multiplied by 4. So I was thinking about multiplying by 4, I guess. It contains some multiples of 4. We want to think about elements of S. At that point of the question, we've already agreed, I think, that elements of S are either multiples of 4 or they're odd numbers. So I started thinking about those two cases to think about where have those numbers come from, which is kind of the theme of parts 2, 3, and 4 is sort of where do elements of S come from. To show that 200 is not in S, you're thinking about, well, how would 200 get to be in S? And to show that they're unique, you think about, well, how do you build them? Where do they come from? So now you've got, well, they either came from numbers about a quarter as large, in which case they're multiples of 4, or numbers that are about half as large, in which case they're odd. Combination of things. Lots of people are asking about typing, and I think I should say that I don't think you can type an answer to this question because of all the subscripts. Some people in chat seem to know how to do notation for subscripts, but especially things like subscript k+1. I think if you were typing answers to this, then it would be a mess. So I think this is a question that people answered on paper, and I don't think you could ask exactly this question. Although see the sample test, because in the sample test we took a past question that had subscripts in, D1, D2 for days of the month, and added an instruction to say in your answer you can type D1, no subscripts or anything, just D1 to mean D subscript 1. I think if I wrote that question for this year's MAT, it would probably use 6 different letters of the alphabet rather than any subscripts, but what do you know? Okay. Yeah, like in chat people are typing stuff and I can't understand what they mean, but I think it would be a bit of a mess. Good, okay. And 2 people say they're not here for the live stream, but thanks for popping in anyway. A way to practice the online format. Katie, there is a practice test on the MAT website. If you can find the MAT website, not the live stream page, but like one up. The live stream page lives underneath the overall MAT page. I think there's a link in the YouTube description to the overall MAT page on the department website. Somewhere on the left, if you scroll down a bit, there is a link to an actual Pearson VUE experience. The pink peanuts was me circling stuff to simplify. I have a relationship from the previous part, right? I know that whenever I see 2 U things with consecutive subscripts, U3 and U4 or whatever like that, whenever I see those, I'm allowed to simplify by writing down the next value of U in the sequence. So whenever I see like U3 and U4, I'm allowed to write down U5 as a way to simplify. I'm using this part loads. So the pink peanuts are me drawing this kind of spot the places where I can use the previous part. U0 plus U1, yes please, I would like to simplify that to U2. U1 plus U2, yes please, I'd like to simplify that to U3, and so on and so on and so on. If you've got 2 U's that are next to each other in the sequence, you get the next term in the sequence. I'm coming around to the idea that they are just Fibonacci numbers for the U's. Katie's not found it. Can someone link Katie? If anyone's able to find the bit I'm talking about, I will also have a look, because I'm about to take a quick break because we're about to hit 6 o'clock. Somebody's off for a further maths lesson in 5 minutes. I don't know what time of day it is. Goodness me. Let's link like this. I've put a link. No, I haven't. I failed to put a link. Copy link. I've put a link. I'm putting a link. Oh my goodness. How am I so bad at Slido? I've been using Slido for years. Let's go. Let's go. I think I did it. Did I do it? Yes, and so did somebody else at the same time. There we go. We've put a link in chat. There is chat. I could have guessed some of that, right? home.pearsonvue.com/OAT/mat-sample. No pets in the test. Oh, not understanding something fundamental with V, part V. What's the relationship for UK plus 2 to the previous parts? Right, okay, let's do a quick example. So sometimes when you see a general statement, it's helpful to change that to a specific statement. So for example, U3 means the number of elements, so if K is 3 of S in, and then this would be, why did I pick 3? Between 8 and 16, not including 16. So then those elements would be, oh, here we go. This is a fun exercise, isn't it? So is 9 in the set? This is hard. So to decide whether elements are in this set or not, 8, 9, 10, 11, 12, 13, 14, 15 or 16. To decide whether these elements are in the set or not, I have to decide, is it a multiple of 4 and it's 4 times something that was in a smaller number that was in S? Really, to work them out, I should first work out small elements of S. Things like the fact that 3 is in S. Is 3 relevant right now? I'm not sure. I think 3 is relevant. And separately, it's relevant that starting at 4. 4 is in S, and so is 7. So then there are some elements that come from this small number, this bit of S. It includes 3, and it includes 4, and it includes, let's figure these brackets, there we go. It includes 3 and 4 and 7. So it's relevant this kind of value of 3 leads on to 12 being in S. And the values of 4 and 7, they're a bit larger. You could double those and add 1. So you get 8 plus 1 is 9. 9 is in the set, great. 7 times 2 plus 1 is 15. So, and those are all of the elements of S in this range, because anything else that was in S in this range would have to be either 4 times something very small over here, or 1 more than twice something that was medium sized over here. And by carefully controlling the sizes of these things and remembering that elements of S are either made by multiplying something in S by 4 or by adding 1 to twice something that's in S. Put it all together. Right. People in chat are now sharing their own solutions for doing subscripts in Discord messages or whatever. Yeah, you should not expect to have access to lingojam.com during a maths test, perhaps, but there you go. Right, it's 6 o'clock. If you've been looking at a screen for an hour straight, then remember to blink. I'm going to drink some water because I've been talking for an hour. If you've been shouting at the screen, correct the subscripts. They're not right. If you've been shouting for an hour, then remember to drink some water. And then do some questions. Rough working in the test, you're given a booklet of stuff to write on. You don't bring your own paper. You get given some, they call it whiteboard paper, I think. It's sort of laminated paper to write on. You get given a pen for that. You don't need to bring stationery. And are there any top secret methods you have from some of the topics on the syllabus to make it easy to understand or do? Mostly it's experience. It's solving other similar problems that helps a bit. I like these ideas about trying small numbers, about building up, trying from the general thing to try a specific case to see if you can make sense of it. Although in here I made a bit of a mess of it, didn't I? This was probably not helpful. You can tell me in chat, I don't mind. This was probably not helpful. I think that water is not allowed, I think, because of all the computers. But I think you can take a, I think there's a process for this. I'll speak to the invigilators or speak to Pearson, I think, because, yeah, having water is important. When I visited a test centre, I think I saw a solution. I can't remember what I saw. You don't need to bring in a pencil case. Has somebody asked about my whiteboard? No. So my whiteboard is Miro. It's fine. This whiteboard paper that you get in the room is when I visited a test centre, it was A4, and you write on it with a whiteboard pen. There's a physical thing in front of you for writing your rough work on. You don't submit your rough work for the MAT, but you do have a thing to scribble notes on. Why does it not double? Oh, because like the binary between each power of 2, there's twice as many values available. Yeah, it kind of does, right? More or less. So there's twice as many numbers in this range, correct? Twice as many numbers. Not all of them are in S. So we're looking at the elements of S. Twice as many numbers in the range. Oh, I've got chat on now. There we go. Twice as many numbers overall in the range. Some of them are in S, but not all of them. To get in S, exclusive club, you've got to be either 4 times something smaller that was in S, or 2n plus 1 for some smaller value of n in there. If somebody doesn't meet the predicted A-level requirements, does the application get directly rejected, even if they do well in that? I don't know what you mean by directly rejected. We look at all the applications and we let everyone do the math before making any decisions. We'd obviously prefer it if people were predicted to make the grades. And I think we'd only make the offer if we thought that there was a chance that you'd actually make the grades that we're looking for. So you might like to talk to your teachers about why they're not predicting you the grades that Oxford needs. The questions are getting a bit off topic. You cannot use paper and pencil because you cannot take in paper and pencil. You will not have a paper and pencil, I am sorry. I am also a paper and pencil sort of person, but for this test, none of those. What do we mark it by? We mark it quite quickly, but Oxford applicants get their scores back for all courses now in January as part of our feedback process in January. What's the long answer questions at the end? Be more like computer science or more like maths? Everybody wants to know whether it's more like computer science or more like maths. And honest answer, those things are very similar. I'm not sure you can tell. If I zoom over here, and I say don't look, but if I zoom in here, I ask you, like, honestly, is this question 5 or is this question 6? I think you saw me zooming, of course, but is this question 5 or is this question 6? They're kind of the same. So I don't think your preparation can really be. I will do this question. I will not do that question because these are the same picture. I mean, they're different questions. I haven't received an email from Christchurch saying they've received my application. Are you expecting an email from Christchurch saying they've received your application? Do you have reason to think that they're going to email you to say they've received your application? You might be able to check in UCAS. Check in UCAS to see what the status is. But I wouldn't panic. Good. What are we going on? Hardest topic in maths. Sorry, Geordie, I saw you ask that a few times. I'm going to pick sequences and series, the sort of stuff we were just talking about with subscripts, because I think people have learnt it relatively recently. There are some things in there like quadratic equations that people learn many years before they do the maths, perhaps, or maybe 2 weeks before they do the maths. I don't know. If you've just learnt quadratic equations, welcome to the club. But I think sequences and series have this property that people have learnt it maybe quite recently, which makes it hard. Also, could do some fun stuff with sequences and series. Right, you get 10 sides of A4, and there is a process for requesting a swap, to swap it out for fresh sheets. Good. Okay, performance in the SMC. I missed that. Senior Maths Challenge is a bit different, isn't it? The topics are different, and, well, yeah, the topics are a bit different. It's also problem solving. It's also tricky questions that are a bit unfamiliar. Slightly different topics. I think MAT gives you more credit for knowing school maths than SMC does. Yeah, cool. Okay. Right, what are we doing next? Let's do the poll again. Not the how was your day poll. What question next? So we've done question 2. I'm not going to remove it. I'm going to look at whatever comes second. If you voted already, that's fine. You don't need to change anything. I should probably have turned this on while everyone was getting a blink, getting a glass of water. What were we doing? We're doing fine. If I'm applying to a place like Imperial Maths, is the question in chat. I don't work for Imperial, so I think this is going to be no comment. The question says, is it easier to get into a BSc than an MAT? Obviously, I have no idea. For Oxford, same. We don't even let you choose between those two when you're applying. We treat everyone the same. For Imperial, you're going to have to ask Imperial. I'm sorry. How much for Olympiad? You know, one person that writes SMC. How much for Olympiad and Maths Challenge are valued in personal statements. If you're happy about what you did and you think it's good preparation for university, you can talk about it, but you don't have to. It's not a qualification. You don't have to declare it. You can talk about it if you like, but remember that you're trying to explain about yourself, and you don't have to list things in your personal statement. It doesn't have to be a comprehensive list of all maths that you've ever done. So up to you. We're not going to systematically compare people's scores or look to see whether people have done it or not and judge people based on that. We've got the maths admissions test for that sort of thing, which all our candidates do. That's good. Yeah. Our candidates are expected to try to do it. What's the right phrase there? Yeah, good. Will we have to have cameras during maths? You do it in a test centre. So you do it in the Pearson Test Centre. I think the test centre does have cameras, partly for security, but you don't have to think about it. You don't do it at home. You do it in a test centre, so not your problem. Good. Okay, question 3 is doing quite well, isn't it, in this voting system? And also 1J. Should we mix it up by looking at a short question quickly? What was 1J this year? Oh, yeah. Circles. Yeah, that's not too bad, right? That's not too bad. You've got to draw a really good picture. Draw a really good picture and you're winging it, right? You've got a square. It's centered on the origin. That's a really good square. Oh, excellent stuff. And a circle with radius r also centered on the origin. Pop. A of r be the area of the region that is inside the circle but outside the square. No. So in my picture, A of r is 0. And I guess it's 0 if r is less than 1. And B of r be the area of the region that is inside the square but outside the circle, which for me is something like 4 minus pi r squared for cutting out the circle. Again, if r is less than 1. And then I don't really know what's going on in this kind of intermediate case where the circle gets a bit larger and starts sticking out the sides. Oh, they're both really complicated in that case, aren't they? Let's move on. If the circle is huge, if r is greater than out to a corner, this thing's really large. If r is greater than root 2, then A of r becomes non-zero, B of r becomes 0. A of r is the area of the region. Am I still on screen? I am still on screen. Area of region inside the circle but outside the square becomes pi r squared minus 4. Do I mean r for radius? Yes, I do. Okay, so then some of these things is 4 minus pi r squared to start off with, and then pi r squared minus 4 later on, and it's something complicated in the middle. So sad quadratic, happy quadratic, something weird in the middle. That's sad quadratic, sad shape, happy shape. Oh, but does this one go down to 0? I think that does go down to 0. And it shouldn't go down to 0, it should go down to not quite 0. Also, is that curving upwards? I can't tell. I don't know what this nonsense is, and that does go down to 0. I'm going to pick D. So I think comes down and goes back up again, curving upwards on that side. I'm going to pick D. That's what I think of 1J. 3 is doing very well in the poll. We should look at 3. Aside from maths and Timur, I don't know resources to get better at quick problem solving. Quite like the senior maths challenge, actually. If you want some multiple choice questions, you asked for multiple choice questions. Other people are talking about the senior maths challenge. I think it's got multiple choice questions in. Yeah, I think I know it does. Good. Thank you, Anonymous, for agreeing with me. How are you meant to gauge where the maximum is, or I think you mean the minimum? Well, I know it's not 0, because if it's 0, both of those areas would have to be 0. I think it's something weird, right? Is the sum of 2 positive numbers? So it's never 0. I think it misses the axis. It'd be nice if that was labelled 0, wouldn't it? 4, 3, 2, 1. That's 0, isn't it? It's got some labels. Use a 0 label, maybe. If that makes it too clear what's going on. I don't know, it's definitely 0. It's 0 in all the cases. Those are the axes, not a trick. That comes down to 0. Okay, it's non-zero. Yeah. Good. They're complicated functions. So this is a weird question where they're complicated functions and you don't actually need to work them out. You just need to work out what's going on in the cases that you can handle. Identifying which of the, again, there's a big general thing, and we're looking at specifics for this. It's question 3, the elliptic curve. Are we now going to talk about elliptic curves? Geordie would like to learn about sequences and series efficiently. There's only about 4 things that you need to know. Don't get much more efficient than that. You can find a summary of them and some brief notes. I think it's about 1 side of A4 if you go to the MAT Livestream. This is the show that you're currently watching. MAT Livestream, and scroll up to sequences and series. which I think was, well, I don't know when, but worksheet number 8, if I numbered them. Number 7, maybe, if you count from 0. 7-SEQ. It's a really good worksheet with 1 page of A4 revision material about sequences. That would be a very efficient way to learn about sequences and series for the purposes of the maths admissions test. Right. I'm trying to get better at promoting my own content. I don't know if anyone's noticed. Yes, it is impossible for those things to sum to 0. Yes. Is that a link about? That looks like a link. Anonymous person has given you a link to somebody else's content, which is allowed. There you go. Good. Okay. So, question 3. I would like to jump in. I might take one more question. I can see one in the queue. Should we do Maxwell's question quickly? There it is in the queue. Sorry. Personal statement: if you don't have any extra supercurriculars. Supercurricular means anything you're doing outside the classroom that's related to the subject you're applying for, which might be maths. If you would like to very quickly find out about some extra bits of maths for free on the internet, this YouTube channel has got some ideas. If you want to see other people's YouTube channels, I understand there are also other YouTube channels with maths ideas on, but it could be as simple as finding a bit of maths you like and having a look to see what's out there on the internet. The internet is getting better and better at having maths content on it. That was another attempt at plugging this channel, you might have noticed. I'm trying to promote the channel a bit more. We do a show called Oxford Online Maths Club, which has ideas for supercurricular maths in it. If you go through the previous videos on this channel, you can find current students talking about their favourite source of mathematics. There you go. Right, okay. Anyone doing joint philosophy? If so, why? A philosophical question in chat. Is anyone applying for maths and philosophy? If so, why? That's made my day. That's really funny. Lots of people apply for maths and philosophy. It's a very interesting course. If so, why? I don't know why that's really made me laugh. Right, okay. Here's a curve. It's got so many points labelled in it, but like we saw a horrible diagram recently on the show, I can't remember when. Horrible diagram where only part of it was relevant at a time. 3 points with the coordinates, blah blah blah, are all on the curve. Yes, and they've all got the same value, the same y coordinate. Ding ding ding. What a good picture. One of the values of a and b. Oh, so this is where y equals 0 if I need the curve, don't I? The name of this curve? What is this? The equation of this curve is y squared minus y is x cubed minus x. I'm going to write that nice and large over here. So y is 0 if 0 minus 0 is x cubed minus x. So if x is 1 or x is 0. Do I mean that? No, I don't think I do. Minus 1. No? Or minus 1. 3 roots. This is cubic. Oh my goodness. I sped up and that was a mistake. Are they non-zero? We told that one of them is negative and one of them is positive. Yes, we are. They are not 0. Always look back up. If there's terms and conditions or inequalities, they're often near the top of the information that you're given. Always look back up again if you're looking for things like that. Extra maths content. Somebody has linked in chat extra maths content. They've just linked to the entire syllabus of every course that's offered at the University of Oxford's maths department, including graduate courses. Here's everything. I guess there's a lot of extra maths in there. That's more than you can deal with in the course of 3 or 4 years by a factor of 2 or 3. Good. Okay. Yeah. Okay. By completing the square, or otherwise, I think I'm going to complete the square. I'm going to find the value of delta. Oh my goodness, what was delta? Oh, the curve only exists. I haven't used this fact yet. Delta is something to do with alpha, beta, and gamma. The curve only exists for some values of x. Oh, so I should maybe complete the square for, I guess, for y, because it's got this quadratic in it. Will that tell me which values of x I can have? Somehow? The cubic will have some sort of minimum or something. the quadratic will have a minimum. That's got to mean something, hasn't it? Yeah, let's think about that. So let's complete the square. So the equation, which I've got over here, look, I forgot I did that. What have I done? I have added a half to both sides for some reason. Why have I done that? I mean minus a quarter. Complete the square. Don't always get it right first time, but complete the square. Good. Okay. So what? Oh, so then the question is something like, for some values of x, this thing is positive. For some values of x, this thing on the right is negative. Don't like the ones where it's negative. I'm only interested in is this positive? Those are the values of x. At the points where it starts being, it kind of changes at the points where this thing is 0. There's sort of some transitions where if this thing is negative, you get no graph because this says square is equal to negative number. So if I draw a little sketch, let's draw a little sketch. X cubed minus x plus a quarter is negative, so no solutions, or no points on the graph here and here. And so the regions that you're going to get are alpha less than x less than beta, and then gamma, up it goes over on the other side to the right of gamma. The switchover points are where, so it changes, the switches are where that function on the right is 0, which is the kind of switching points, or the extreme values. Let's call them that because that's a fun phrase. Extreme values of x when this thing is 0, which is when y is a half. So I think delta is 1/2. Delta is like the name of that y value. Or otherwise, and you differentiated, yeah, seems all right. You have to know how to differentiate this, right? With respect to x, that's kind of like the chain rule or something. Off you go, have fun. Sometimes or otherwise, the otherwise way is harder. Someone in chat has gone for it. Anonymous has got a great answer, which is, why did you apply to philosophy? Answer, why not? Excellent stuff. Something something square root negative number. Yeah, it's that. But thinking carefully about what that's got to do with the values of x and y, that x is a cubic, which is sometimes negative. But x appears in a cubic, which is sometimes negative. Y appears inside this quadratic, which once you've added a quarter to both sides is non-negative. So there you go. Part 3 is easy if you spot that this is now y minus delta squared, if delta is the number 1/2. So this is easy if you spot that symmetric about the line y equals delta means that values of y larger than delta and values of y a corresponding amount less than delta. Let's write that down. Y is delta plus t and y is delta minus. I don't know why I picked t. I've run out of t. But delta plus t and delta minus t is kind of the corresponding amount above or below that value of y. They have the same value of y minus delta squared, well, namely t squared. I guess I wanted a name for this y minus delta thing. Once again, there's a theme we've seen before. Giving the thing the name makes it powerful. Once you've decided to call it t, there's a name for this thing that I'm doing with my hands and saying like the corresponding amount less. There's so many words when you could just say t for that difference. Right, okay. Find a cubic equation in x which has roots alpha, beta, and gamma. Oh, that's the one we were already talking about. We have a picture of it here. Here it is. This cubic has roots alpha, beta, and gamma. Justify your answer? Well, yes, those are the points where it changes from either having some solutions or not. Ha, good. Okay. And find the value of alpha plus beta plus gamma. So this cubic factorizes We know all of the roots. Has roots, not 12, alpha, beta, and gamma. So it's x minus alpha, x minus beta, x minus gamma. Really, I should have half a sentence here to say leading coefficient is 1. There's another polynomial, right, which has the same roots but has a factor of 2 out the front. How do I know it's not that one? You know, out the front would give it a coefficient of x cubed, right? So, but I should say something. Leading coefficient is 1. So I get half a mark or something for remembering that. Oh yeah, it's literally that. Don't think it matters. Oh, it matters a tiny bit. And then the coefficient of multiplying out. So if I multiply this out, I've seen stuff like this before, I think. I can't remember when people learn this, but you know, it's the concept of multiplying out. Multiply out. It's the coefficient of x squared is minus alpha beta minus gamma, but it's also just 0. So this sum is 0. Good. Okay. And last part is awful in terms of algebra, but not too bad in terms of, you know, just writing down the idea. We're going to try and convert this geometry idea to an algebra idea, I think. We've been having great successes so far with bits of algebra down the side. Let's C denote the circle which has the points alpha delta and beta delta as ends of a diameter. Do you remember that the diameter is the line right through the middle of the circle? Middle of the circle is quite important, also known as the centre of the circle. So the centre of the circle would be at, where's the centre? What's the radius? Because you know the diameter is made of twice the radius, right? Once you know the diameter, once you know the locations of 2 points on the diameter, the opposite ends of the diameter, you know the radius and you know the centre. And those are the 2 bits of information that you need to write down an equation for that circle. So C has equation coming down here for part 6. C has equation x minus, and then, so this x coordinate is going to be something like the midpoint of those two, so alpha plus beta over 2, like an average. And the y coordinate is going to be, well, everything's on the line, y equals delta over there, isn't it? And the, I suppose the radius is something like beta minus alpha. Which one's larger? Is beta positive? I'll go and check in a second. I think it's this squared. I've divided by 2 because I want twice the radius. Going back up, looks like beta's the larger one. Yes, beta is larger than alpha. Reading across that inequality at the top. Beta is larger than alpha, so I should do it this way around. I'm squaring it, so maybe it doesn't matter. But I wanted to get it the right way around in my head. Beta minus alpha squared over 2. Good. Okay. What was I doing? Sorry. Write down the equation of C. Oh, that was something I was supposed to do. Good. Learn that this week in year 13 further maths. It is also just multiplying out. So I'm glad you learned it in further maths, but also multiplying out. I reckon we can do this. Okay, show that the C intersects S at 2 other points. Oh my goodness. So I'm not going to think geometrically at all. That's my plan. S has equation. Here's the equation again. I had it a second ago. X cubed minus x. Oh, we factorised it, didn't we? We wrote it like this. This y minus delta is familiar. So I have an equation. I can just substitute it in. I should just substitute this in. Like, I'll draw another pink peanut thing, but this one is. Look, here's a y minus delta squared from, we had y minus a half squared just off the top of the screen there. There it is. We had that before. We want that again now for the y component squared of the bit of the equation of a circle that is something to do with the distance from the centre of the circle. Oh my goodness, but this is the same. So I should just sort of sub it in, get a cubic. So intersection. So intersecting these things sounds complicated. I don't know why I've written this one first. Sorry, that was not very helpful of me, but I'm just subbing it in. I've also swapped, I've swapped the order of the terms. What am I doing? Never mind. At these values of x, which satisfy some horrible cubic equation. Okay. what shall I do? I want to show that C intersects S at two other points. Find their common x coordinate. Okay, so I'm going to find the value of x that does this. So here, I suppose that it's relevant that these 2 points, x is beta, should work. I can see a question in chat that says, how did you get the deltas in here? Delta is just, at this stage, delta is just the number 1/2. So wherever I see a 1/2, I put a delta. I got y minus delta in this equation with the circle because I'm thinking about y coordinates, which involves, well, the center. The center is this, halfway in between these points, alpha plus beta over 2, delta plus delta over 2, for the midpoint of that line segment. And I have y minus delta squared in the equation for the s because, well, I rearranged it to have a y minus a half a while ago, and a half is just delta. Delta is a half. Where does gamma come in? At this stage of the question, we already know that alpha plus beta plus gamma is just 0 from the previous thing. So you're right, gamma might not come into this because gamma is just, at this stage of the question, we've achieved so much together. Gamma is just negative alpha, negative beta. That's not how people talk. Negative alpha minus beta. That's what people say. Yeah, cool. Okay. Why is no one liking the state school comment? Why is no one liking it? Maybe because it's asking for likes, which people don't enjoy. How do I get that? Oh no, I've read that already. How are you meant to know if a question wants the answer in terms of stuff in the question? You do your best. And if it's only possible to do it in terms of variables in the question, then that is in general what happens. But if there's variables around, the answer will depend on those things. This one says in terms of gamma, because the answer depends on, well, you could think of it as depending on any of these things because they're all related at this point, but you are being asked to write your answer in terms of gamma for this part of the question. So I think I know the roots of this one. This is another cubic. I'm going to be a bit cheeky. I'm going to say the coefficient of the roots of this cubic, just got one eye on the clock, sum to -1, because the coefficient of x squared is 1. If you believed me up here, the coefficient of x squared is 1 if I multiply that by the square. Coefficient of x squared is 1, but that's negative the sum of the roots from multiplying out. And I know 2 of the roots are alpha and beta. So alpha plus beta plus other root. I should have given that a name. Look, giving it a name would be so much nicer. Alpha plus beta plus other root is supposed to be -1. So this other root, this common x coordinate in terms of the other root is -1 minus alpha minus beta. Oh, that's just -1 plus gamma, which is why they've asked you to write it in gamma, because, well, we have this relationship up here which allows us to see whenever we see alpha plus beta to switch it around. I could have done that in here, I suppose. I have this alpha plus beta. I could have opted to just start writing this minus alpha plus beta as something involving gamma, like x plus gamma over 2 squared. Maybe that'd be nice. I don't know. It's okay. Okay at best. Okay, what's going on here in chat? Let's catch up. I think I've done the maths for this. The key idea is, if you're just talking strategy, let's get green pen out, which is what we used for strategy before a little bit. Writing the equations out. They tell you to write out the equation for C, also copying out the equation for S, and try to compare. Even if you hadn't spotted this delta 1/2 thing, you could still eliminate y squared or something. I think you probably do need to spot the coefficient of y once you've multiplied out here. There's a y squared minus y going on, and that's also what's going on here. You kind of need to remember that delta is 1/2, I think. So plugging together different parts of the questions again. But the main idea here was to turn the equations turn the geometry into equations. And there's an idea about roots of polynomials, which has recurred here as well. Factorizations. There was an idea around here to just sort of understand the values in the question and to look back up So we're going to go look up for a kind of strategy idea to just like compare to the things in the question. Yeah, so other route, let's redo that again. There's a suggestion in chat, which I'll just switch back on again. What should I focus more on, past paper questions or topic revision? Geordie, I'd start by doing topic revision. If you learnt about sequences and series from the notes that somebody linked you to half an hour ago, then maybe you've just learnt it and you should have a revision, have a look at that first. There are lots of past paper questions. You don't need to do all of them. Having a look at some of them might give you an idea of what questions are like, but there you go. Okay, I'm going to talk about the other route because there's a request in chat to talk about the other route part because that was pretty bad. I agree, you can say it's fine. I think that bit was pretty bad that I did on the screen. You're allowed to say. Yeah, there you go. There's a nicer expression in chat as well, just disappearing off the end. And there's questions about, yeah, you know, if you're unable to sit the mat, then there's a special considerations process. You let us know, and we consider your application. If we have to, we consider applications without MAT scores. We'd obviously prefer it if you got to sit the test. But yeah, every year some people are ill or unable to take the test on the day, and there's a special considerations process. Please have a look at the tests bit of the website if that happens to you. James and Kelly, I'm applying for CS at Oxford next year. Hooray! Studying prep now. Any tips? Yeah, loads. Loads of tips. All of them about problem solving and about trying to get a taste of what the subject might be like and trying some bits of things outside the classroom. What does Callie say? Callie's done a great answer here. You don't get to see it on the screen up here, but Callie's done a great answer. About remaining calm. Interviews are not nearly as intimidating as they might seem. The tutors are very nice and will give you hints if you don't completely understand the question. If it gets you to the answer, you will still get points for it. If you get worked up, you won't be able to think clearly, so try to avoid this. Thanks, Callie. There's lots of interview advice there about staying calm and listening to what's going on. I am going to do the other route part. I think the other route part is good. Right, this was cheeky, and I said it was cheeky live. Let's work on that. So we have this cubic, which I'm going to copy out. X cubed minus x plus 1/4 plus x squared minus alpha plus beta x. I am regretting, that could be a gamma, couldn't it? That could be a gamma. Plus alpha plus beta squared over 2, or over 2 squared, and then minus beta minus alpha squared over 2 equals 0. Ooh, difference of 2 squares. One moment, please. Alpha squared over 2 over 4, alpha squared over 4, beta squared over 4. The middle term, though, fails to cancel and gives us 2 alpha beta over 4 here, and negative 2 alpha beta over 4 here, which is beautiful, just turns into an alpha beta. That's pretty good. Difference of 2 squares. Oh, there's a quarter over here as well. I don't love that. Can I make that go away? Don't like that at all. Ah, well, never mind. It's not going away. I asked nicely and it didn't go away. I'm trying to group the terms together a little bit. I don't know if you can see me doing that. There we go. Okay, grouping terms together a little bit. I've got a constant down here. I've got gamma. I'm going to write gamma minus 1. Okay. That's interesting. This is very interesting. This quarter over here. It's telling me facts about alpha and beta, I think. So, ideas. This has got 3 roots, maybe. It's a cubic, so it might have 3 roots. In terms of a geometry problem, which I never drew, so I'm going to go back and draw the geometry problem that we're talking about. Not a sticky note, a circle. There we go. In terms of the geometry problem, we're doing something like this. We have a circle in a different colour that is, its diameter is supposed to be A to B, and it intersects. Oh my goodness, look at this. That is hard to see. It intersects with the curve at some other point over here. There's a common x coordinate that's shared between these two. But it also intersects the curve at this point and that point. There's the diameter between those 2 points. Those points of the circle lie on the diameter, so they lie on both the curve at the start of the question and this circle. So it should be the case that if I plug in alpha or beta for the x coordinate, that should be consistent. It should lie on both curves. It should lie on the intersection. So it should be the case that alpha and beta should work. Alpha and beta should work. What's the other root? And that's the kind of question. We're looking for the other point between alpha and beta. What do they say in the question? Two other points. Oh, yeah, so the symmetry, the above and below stuff, the above and below that line. Find the common x coordinate in terms of vocabulary. We're just going to find the x coordinate. Just going to work it out. So if we call it, we've got so many Greek letters flying around. Let's go for another one. Let's go phi. Then the cubic is this cubic, this new cubic. This cubic is x minus alpha, x minus beta, x minus phi. Multiply out. And if you compare the coefficients, so again I've got a thing and another thing that are equal, so I should compare them, compare the coefficient. And in fact, if you compare the coefficient of x squared, then you find something very surprising, which is that minus alpha minus beta minus phi is equal to 1. So rearranging that a little bit, you get phi is minus 1 plus gamma. Yeah, the roots add together to minus 1. This is a general fact about cubics. Should we learn the general fact about cubics? Let's learn the general fact about cubics. In general, if you multiply this out, you get the following. You get x cubed, you get this many x squareds, you get this many x's, and you get this many constant terms. There is a pattern here. I've put equal 0, I don't mean that. There is a pattern here. Fans of patterns, you can maybe generalize this. If you're doing further maths, you will at some point learn a way to generalize this, but maybe you've already seen it just from the way it is. The plus and minus signs are a bit annoying, but overall there is a thing going on here. So you multiply out a cubic. I've multiplied out cubics a lot of times. If that's not me actually multiplying it out, that's just me knowing what you get, which you can see why that would be nice. If you would like this power, then all you need to do is find a scrap of paper and one time multiply out this thing slowly, take your time, make sure you get all of the terms. There should be about 8 of them. I hope you get these terms. Yeah. Good. Can I talk about the Birchland-Swinnerton Dyer conjecture in chat? No. I literally can't. Good, okay. That was question 3, I think. Oh, sorry to clap at the microphone. That's not very good etiquette, is it? I'm getting excited too, totally. There we go. There were some votes for other questions. I'm going to have a quick look. This is not supposed to be... Can you use roots of a polynomial instead of expanding it? Yeah, probably. I don't know what you're going to do with the roots of a polynomial, but that's what these things are. They're roots of a polynomial. If you know facts about the roots of a polynomial, go for it. There are no instructions not to do that. If the question doesn't want us to do it, then it should tell us not to do it. I'm going to have a quick look at this vote. The easiest way for me to see the votes is to switch it back on. Other votes for other long questions, 5 and 4. I've got 17 minutes. 17 minutes. I can already tell I'm talking too fast. I've sped up quite a lot. Sorry for the people at home watching at double speed. Well, obviously for this bit, it's pretty good to be listening at double speed. This is just some nonsense of me talking to the screen while I remember what I'm doing and drink water. But, you know, for other bits, I know I'm talking too fast. Sorry. Might be doing a little bit more of that before 7 o'clock. Yeah, Katie says polynomials are a concept within the further maths spec. It depends what you mean by polynomials. Multiplying this out and talking about how it, by the factor theorem, has roots like this. That is very much not further maths. It's A-level maths. It's on the maths syllabus. It's something getting from the idea that a general cubic, if you know the roots, then you can start pulling out factors. That's something that I expect people to be able to do. I agree that this particular fact seems to be something that further maths people are very, very happy with. Maybe that makes it a weaker question, but it's factor theorem and multiplying out. Part of that comes down to, I guess, if you're doing maths and further maths in parallel, there are some topics that you haven't seen yet. You've only just got onto sequences and series, for example, instead of learning it ages ago. But on the other hand, you have maybe seen extra facts about polynomials that are not on the math syllabus. I think is less helpful in terms of math. You shouldn't worry that that feels like an advantage. They found one of their topics that everybody has about another entire section of maths, like roughly half an A level. If you're doing maths and further maths in series, then you already know so much more maths A level stuff that's not here from all the other bits of A level maths, the second half of A level maths. But if you're doing maths and further maths in parallel, you already know a bunch of further maths. So basically anyone watching this who's doing A levels, including maths and further maths, knows essentially twice as much maths as I'm talking about. And I think it makes sense that when one of those topics, or anything close to one of those topics comes up, people are quite excited. But don't worry, you will end up with the same, you'll end up with literally the same maths in a different order. Okay, good. It is still surprising to me that both of these things are, oh well, never mind. Teaching is really complicated, isn't it? Somebody's just asked for time management tips. That is excellent timing, because I have 14 minutes and I'm going to try and talk about question 5, and I'm grinning. I can see in the camera that I'm grinning because 14 minutes is quite fast. I'm going to do my best, but you asked for question 5 in the vote. Let's see. I was talking about sum of roots. That's all I wanted to say. Good. Just a simple fact. Compare coefficients is a thing that you learn early on, right? Good. Okay. Eating sweets. Question 5. Let's have a look. Right. I'm going to get these wrong so many times. Here we go. Miriam counts the sunny days that there have been so far, including this one, and eats that many sweets. So if it's been raining the whole holiday, no sweets for Miriam. As soon as it gets sunny, Miriam starts upping that count, and it's a daily count. So once it's been sunny, Miriam will keep eating sweets. This number's only going up. It's sunny again later, that ups the count for Miriam. Hooray, 4 sweets. And then even though it's raining on this day, Miriam is still eating 4. I like to check that I've understood along the way. They've given me this example. I'm going to read through it. And I don't read it just going 0, 1, 2, 2, 2, 2, 2, 3, 4, 4. I'm trying to make it a story. Adam eats sweets on rainy days. If day K of the holiday is rainy, he eats K sweets only on rainy days. So if it's sunny, Adam is eating 0. That is the link. S's go with zeros for Adam. K of the holiday is rainy, then he eats K sweets on that day. So 1. And then the rule here is 4, 5, 8 is the same as the number of the day. That's the pattern. So 0 if it's S, number if it's raining. Okay. Tally like this, and in this case, they've eaten the same number of sweets. It's 18. Have I understood that? Adding works. I'm overdoing it. 18, 4, 8, 11, 12, 13, 14, 15, 16, 17, 18. Yep, okay, good. Okay, I've done some checks. I think I understand what's going on. Well, at least I understand what's going on in the question. I'm going to keep that table there while I read this. Lead to Miriam eating the greatest number of sweets in total and the least number of parts of the question that I'm being asked to do. So my understanding is that Miriam just ups the count. So if it's sunny early on, so for the first 15 days, then sure, Miriam's going to eat loads of sweets because each one will contribute the maximum possible remaining amount of time. Miriam eats another sweet, even though it's raining afterwards. Miriam eats more sweets afterwards. So sunny early on, and then the least or fewest or whatever is if it's sunny late on. So if it's rainy first, then I'm losing letters all over the place. If it's 15R first, then 15S in a row. That's loads of not eating sweets. In this case, each day of sun has the minimal possible effect because it comes so late that Miriam doesn't get to eat many sweets as a result of that. I've got to do some adding. I think it's going to be an arithmetic sequence because I can see these counting numbers, and when I thought about this, I noticed I was adding together some counting numbers. If it's all late on, then it's loads of zeros, isn't it? no sweets, followed by then finally 1, 2, 3, 4 up to 15. So that sum is there was an arithmetic sequence going on there, which is something like, is it 120? Yes, 120 or something. And in this previous case, it goes something like 1, 2, 3, 4, 5 up to 15, and then it rains for 15 days. But those 15 rainy days, Miriam keeps eating sweets like that. So it's 120 plus 15 squared, which is something like 225, so 345. I recognise that number. Is this question about sequences? Not really. I mean, a little bit. I mean, I had to use the... Yeah, I suppose it is really, because I've had to use this fact about adding together the numbers from 1 to 15. You might know that as triangular numbers. You might know facts about that. Yeah, it's kind of a sequence in there, isn't it? If you put commas in, it looks exactly like a sequence. That's a silly thing to say, I'm sorry. Okay. Yes, good. I will do a fun fact about hair care if I get through this. If I get through this question in time, for the people who keep asking about hair in chat. Good. In the two cases mentioned in part I, so these two we've worked out. Two questions mentioned in I. We're being asked how many sweets does Adam eat? Which is interesting. This is one where extreme, sunny first, then rainy, or rainy then sunny. Part I, Adam eats the same number of sweets as Miriam in each of these cases. Okay, so in the first case, the 15s first. What was Adam's rule? Adam only eats sweets on rainy days. So he watches these 15 sunny days with kind of no sweets. But then it rains. And Adam eats loads. 16, because Adam's rule is that it matches the day number. And then 17, and then 18. Oh my goodness. No one can stop Adam. He is going to add together the numbers from 16 to 30, for which I think I need some sort of formula. So the sum there is something like, what do? You add the first and last, you divide by 2, you multiply by the number. You're better at this than me in chat, aren't you? I've got to do 23 times 15 now. That feels unfair. 230 plus another half is 230 plus 115. Oh yeah, 345 again. Good. Not exactly how multiplying works, is it? But never mind. Good, 345, the same number. And in the other case, Adam eats all the sweets on those first 15 rainy days, and it is just 1 plus 2 plus 3 plus 15 on those first. I still can't spell the word first. I keep writing fist. Or rainy. It's getting worse. Rainy days. Good. Wow. Does you actually have a mat at 5 AM? That doesn't sound. You should maybe get in touch. Maybe get in touch with Pearson or us. Okay, good. Right, the question now talks about swapping. So here's the swap. We arranged to swap a rainy day with a sunny day. So we had some previous bit of sequence. Oh, there's the word sequence. Okay, good. Swap a sunny and a rainy day. So maybe before, this was day, I don't know, k or something, and this was day k plus 1. And it was sunny before, rainy afterwards. In which case, Miriam would have some stuff going on beforehand, some stuff going on afterwards, which I guess would be the same because Miriam counts the sunny days. So when I do this switch, that stuff's not going to change. And Adam doesn't care about the previous days. Adam just looks at the day number. So beforehand, Miriam would have on this sunny day something like, or some complicated number n, depending on how many sunny days are up to, including this one, and then n again because it's raining, but Miriam has already seen n, where n is the number of s up to day k, including that one. Adam, meanwhile, is doing something complicated like having k plus 1 sweets here and none over here. And I'm just going to do a simple comparison to say what's going on after is to say, well, you've got this block that now goes, if you switch them like this with some more text over here, and I need to write out a sentence to explain why the stuff afterwards is the same because Adam doesn't care and Miriam is counting and the count is the same. But afterwards, I guess this is n-1 because Miriam hasn't seen this sunny day yet. It's been arranged to be later. So Miriam gets fewer sweets, but so does Adam. Adam gets fewer sweets. Bothy. The handwriting is getting worse and worse. Both decrease by 1. So they're not. I'm not saying that 2n is the same as k plus 1. I'm just saying that from the before picture and the after picture, both of these things have decreased by 1. Let's look at an example up here. So up here, which way around was I? I was sunny on the left. Up here, if you switch these two around to be RS instead for days 7 and 8 to switch out this box, then Miriam at this point has only seen 3 sunny days, so she's still having 3 sweets, and then gets to have 4 on that day, and Adam gets to have 7 and 0, which is 1 fewer. And okay, not a great example, because in this case 4 plus 4 is 8, so not a good example. Yep, there were no good examples available to me. Good. It doesn't have to be exactly the same inside the box, but the total changes. I have before and after swapped. Oh, if I have before rainy day with a sunny day that immediately follows it. Oh, yeah, the other way around. Fine, okay, in that case they're both increased by 1. Please switch the pictures. Okay, whoops, thank you, Addy. What are the 2 days are reversed? Like, what if it was originally RS? Yeah, okay, good question, Katie, because that's what's in the question. If it's originally this, whoops, let's go before, after. I sort of should probably redefine this a tiny bit. It doesn't make too much sense anymore, but the punchline is kind of the same. That if before it was like this, Adam was having K sweets, now the rainy day comes later and has K plus 1. If it switches that way around. Before, Miriam had to wait to see this sunny day, so it was 1 extra day of having n-1 sweets, whatever n is. It doesn't matter at all what n is, but n-1 sweets, and then got to celebrate by having n sweets on day s. Whereas if that sunny day comes earlier, then Miriam gets to increase the count up to n earlier. 1 day earlier means 1 extra sweet. And nothing else changes. And I think I do want a sentence in here somewhere saying nothing else changes. Final idea for part 4 is that you can use this starting from an extreme case and switching sunny and rainy days to shuffle them into position. You can make any sequence of sunny and rainy days. If it's before and after this way around, moving the sunny days left, then what we could do is start with the situation where all the sunny days are at the end and make that into what actually happened, the reality of the situation, by shuffling the sunny days to do 1 switch at a time, to move that first sunny day earlier to get it in position, and then to move the second sunny day 1 shuffle at a time to get it in position for the second sunny day, to shuffle them into the right positions. Each time you do a shuffle, the number of sweets that Miriam and Adam have is fair, it remains fair. We checked in parts 1 and 2 that it starts fair, the initial configuration with 15 sunny days at the end, a hypothetical winter followed by summer or whatever. It's all summer, a hypothetical rainstorm at the start of the holiday, and then we can consider moving the sunny days earlier until they're in position for what actually happened. It's really nice. Part 3 is just counting, I'm afraid. It's just this idea that if that sunny day comes 1 day earlier, then Adam has to wait, which Adam likes because Adam's rule is based on the day number. So if Adam waits 1 extra day for the rain, then Adam gets 1 extra sweet. And if Miriam increases the count every time Miriam sees a sunny day, if that sunny day comes earlier, Miriam increases the count 1 day earlier. But most things are unchanged. Miriam is eventually going to see 15 days, eventually going to see 15 sunny days. Miriam always ends up having 15 Sweets on the last day. Amazing. Adam might not have any sweets on the last day. Depends if it's sunny. Good. Somebody has registered the username haircareman. Respect that, I suppose. Good to see. The fun fact is that I've been cutting my own hair since the pandemic. I've been cutting my own hair for 4 and a bit years. I don't know if I'm going to go back. It's going all right. It hasn't gone terrible. It did go terrible at one point. I cut off most of my hair by mistake. It's pretty bad. It was during live streams as well, so it was in between live streams. I cut off a significant amount of my hair. Self-imposed bald spot. That's the fun fact. So yeah, don't take hair care tips from me. I'm lucky that I've got hair. Please complete your booking by October 4th. Please do all of the steps to register for the test, not just on the system. Please book the test. St Catherine's College, I think, did have issues with concrete. I don't know how long it will take for those to be sorted out. I don't know, for example, if by next year the plan is to have the college back to a normal experience or not. In the meantime, I know that students are getting, I think, some support from other colleges. I might need to check that, but there was a bit of time where at least staff were coming over to New College to use our canteen. Am I live on Sunday? Yes, I'm doing my personal Twitch live stream on Sunday. My favourite college is New College because they're the one who employ me to do a little bit of teaching. I do a little bit of teaching. I don't think I can do any more math questions. I'll do one that I can see. The maximum number of points you can get is 100. For a breakdown of where the marks are, you can have a look at the MAT website, which is in the YouTube description, or hopefully if you type Oxford MAT Submissions Test into anything, then you can find out what's going on. But don't type it into ChatGPT, because ChatGPT is trained on old data and the format is slightly different for this year. I don't know if ChatGPT has noticed yet, but yeah, try checking the website that's literally in the YouTube description link. Good. Cool. Okay, can you answer part 4 with a counterexample? Yeah, so the counterexample, it would be a kind of proof by contradiction counterexample, I think. It would be something like, if they're having different numbers of sweets, then start doing some shuffling, and it will stay different until you've switched all the sunny days to one of the cases that we've seen before. I think your contradiction, proof by contradiction, sort of suppose that it's different, well then it would be different in lots of cases due to the switching. It would be different in one of those cases in part 1 or 2. Oh, it was the same in parts 1 and 2, therefore we're done. Maybe that's what you mean. There aren't any proper counterexamples because the fact is true. So okay. Oh right. The answer is yes. I didn't realise it was a yes/no question. Sorry. The answer is yes. They do eat the same number of sweets in total. Sorry. Yes. Good. Okay. Is that a YouTube video of me with no hair? Let's find out. It is a YouTube video of my personal statement. Fun. Almost worse. Good. Yep, it's entirely to do with part 3 at the end there. Good. I've run out of time. Thanks for watching the live stream. We'll be back next week to talk about the 2021 paper, which I think has one of my favourite questions in it. I think it's got one of my favourite questions in. Look, I'm trying to promote future content as well. What do we like? Different questions count for different numbers. They still want to know about MAT details. Please check the website when we're not live. You can find this out online. It's going to be okay. I believe in you. Good. Am I reading things that am I in a loop? I think I'm in a loop. Good. Right. Take care, everyone. See you next week for part of the loop. We'll be back in 166 hours for another episode of the Oxford MAT livestream. Take care. Goodbye.